Hello everyone. This is a DC regulated adjustable power supply from Nice Power, unit model SPS W605. It is rated with an input voltage of 230 volts AC with a variable DC output up to 60 volts DC and a maximum current of 5 amperes DC. A cooling fan is also installed at the back, which automatically turns on and off to manage temperature. It is protected at the AC input side by a 3 ampere fuse. For this test, I'm going to connect my Bosca 25 watt solar lamp to the DC power supply. The purpose is to determine what voltage level would the lamp automatically turn on and off. The solar light is designed to be connected to its solar panel, which provides DC voltage to charge the light's internal battery. I have previously determined in another practical experiment, using only a voltmeter and ocular observation, that the lamp automatically turns on at night and turns off at daybreak due to a voltage threshold. There is a certain level of DC voltage output from the solar panel, which dictates whether the light turns on or off. I linked a video about it below. Today, however, I will temporarily remove the solar panel from the equation and replace it with the DC power supply. First, set the DC power supply to 7.2 volts to simulate the no-load maximum voltage output of the solar panel. Set the maximum current at 2 amperes. These two values, 7.2 volts and 2 amperes, are based on the nameplate rating of the solar panel. To test the lamp using the remote control on full auto. It turns on because it does not detect any voltage at its input terminals. I will manually turn this off now using the off button. Using this diagram I made of the correct polarity of the solar lamp's terminal connection, I will use another set of test leads with special alligator clips so that I can connect the male plug to the power supply. I will now put the lamp in full auto control using this button. Notice that the lamp turned on, and it turned on because it did not detect voltage at its terminals. The lamp thinks that it is nighttime. I will now connect the solar lamp to the DC power supply and observe what will happen. The lamp automatically turned off and begins charging. We know that it is charging because the power supply switched from constant voltage mode to constant current mode, and it is reading 2 amperes. Voltage dropped from 7.2 volts to 4.18 volts. I will now reduce voltage to simulate the low voltage of the solar panel during evening. So at around 3.7 volts, the charging current dropped significantly. It is now only 344 milliamperes. And at 3.25 volts, charging stopped totally. At around 1.3 volts, the lamp automatically turned on. The solar lamp thinks that it is nighttime due to the very low voltage. I will now ramp up the voltage to simulate the rising of the sun at dawn. At around 3 volts, the lamp automatically turned off. At 3.47, it now begins charging. And at 4.17 volts, we have a charging current of 2 amperes. The solar lamp I used in this experiment is totally brand new and it has just been delivered today. It is only partially charged. So results could vary depending on several environmental and technical factors when other units are used. But the result of this power supply test confirms that the solar lamp on full auto control is truly being managed by the voltage output of its solar panel. For this brand new unit, a low voltage threshold of about 1.3 volts and below will turn it on by using its internal battery, while an increase in voltage from 3 volts to 7.2 volts will turn it off and cause it to charge its internal battery. Thank you for watching.